You could do one of the last four. That's what I'm stuck on.
I think it's J ready to go. So let me get that one up. Give me just a second. Figure out where I put that. Okay, and then I think I should be able to share that one with you guys. And then I'll just kind of talk through what I did on it. Okay. So here's J, right? You guys can all see the dg d theta, right?
Substitution.
And so the first thing I did was I separated the variables, right? So the G I moved over to the side with the dg, the d theta I moved over to the right side. So then that put all of the thetas on the right and the G's on the left. So far, so good? Okay, so then I recognized that there was a function inside the sine theta. It wasn't just a theta that was inside, it was a theta squared. And so I did this u substitution and I made u equal that inside function theta squared. And so then when you do the u substitution, you take the derivative of both sides. When you take the derivative of the theta squared, you have to remember to include the d theta on that side. And then the idea is to isolate that d theta. So then this 1/2 theta du is what I'm going to substitute into the d theta that's right here. So that's what this right here is that's that d theta becoming the 1/2 theta du. And then here the theta squared became the u. And then I had the theta and the theta there cancel out because that theta is in the denominator. How's everybody doing so far? Okay. So then that left a 1/2 du here, and that 1/2, which is a coefficient, I pulled out in front of that integrand. And when I pulled that 1/2 out, then I was just integrating a sine theta, or sorry, a sine u du now on that right side. And because the derivative of cosine is negative sine, I made the antiderivative be a negative cosine u. And remember, you should always check your antiderivatives. Is the antiderivative, or sorry, is the derivative of this equal to that right there? Okay, so the 1/2 is still there. The derivative of negative cosine is going to be a positive sine because the derivative of cosine is negative sine. And so then the negatives cancel out to give us the positive sign. And then on the left side, the antiderivative of g would be the g squared times the reciprocal of that new exponent. And then you do the plus c on just the one side. So far, so good? Okay. So then I put the theta squared back in for u. And then I took that initial condition that I copied down from here originally. This is I wrote this because I knew it wasn't super clear. So I kind of did this to help me realize that that value in the parentheses is the theta value, and that value there is the g value, because that's what g of something equals. So g is the -2. So I put the -2 into g, and I put the root pi/3 into the theta. And so that's what I did at that point. And then just simplified that. Over here, it's kind of hard to see, but this is where I worked out what the cosine of pi over 3 was. So over here, if you can see there, I put a pi over 3 angle there. So that's like a 60-degree angle. So then I knew that that one there is the 30-degree angle. So then I have my 1, my root 3, and my 2. Cosine then is the adjacent over the hypotenuse. So I got that cosine of pi over 3 was 1/2. And so then I got that C is the 2 1/4. So far, so good. How's the pace of this? Are you guys, the pace of this going too fast, too slow? Is it okay? Going okay, okay. All right, so then I took this expression back and I substituted the C into that. And I also, because I had a 1/2 there and there, I multiply both sides by 2 so that that would cancel out the 1/2. And then that left me with a 2C because I distributed a 2 through all of that. Other ways you could have done that, I saw one person that already turned theirs in. They distributed a 2 before they solved for C. And so then they ended up finding a different C than I found. But everything works out the same by doing it that way. Anyway, so then it was just a matter of solving for G and then substituting in that square root of pi over 2 because that's what the final answer that they're looking for is the value of G at the square root of pi over 2. So I'll leave that there and let you guys ask questions if you have any. So I only have this one and D worked out already. The other ones, I'll probably just go through and answer specific questions as we go. But I will go ahead and show you guys D next. D had a particularly tough antiderivative. You guys all done with that one? Ready for D? Okay. So let me get rid of that one then. And then I'll open up D. And I will share that one. So Christine, since you've already seen D, if you want to check back in later, you can, or just hang out for now, you can. Okay, so there's D. Because of the y prime, you really could make this in terms of any variable. Dy dx felt normal to me, so I used the dy dx. And then I rewrote the square root of the 3 minus 1 as a 3 minus 1 to the 1/2. And then I separated the variables. And so the dx came to this side. I left the 2 there, and then I brought that whole 3 y minus 1 to the 1/2 to the left side there by dividing it over here. And then I rewrote it because this 3y minus 1 to the 1/2 was in the denominator there. I rewrote it as a 3y minus 1 to the negative 1/2. And then when I went to integrate both sides, again, I could see that I had an inside function. And so I used u substitution. I don't think you really need to use u substitution on this one because the derivative of the inside is just a 3, which is a constant. And so you could just multiply by the reciprocal of the derivative of that inside. So you don't really need to go through these steps here if what I just said makes sense to you. But I did go through the u substitution because I know that that is kind of a clear step-by-step way to figure out how to do these. So my derivative of the 3y minus 1 is the 3, and then times dy, got the dy by itself. And so then that 1/3 du is what I ended up having to substitute into the dy. Okay. So Lydia, you just got in here. We're in the middle of the card sort D right now.
Great.
Yeah, we just did J also, and I am recording this, so you can always go back and rewatch that one later if you need to. Okay, so at this point here, after my u substitution, right, there's my u to the negative 1/2. There's my dy, which is the 1/3 du. That 1/3 I brought out to the front, and then I did the antiderivative of the u to the negative 1/2. So because this is a power function here, you add 1 to the exponent, making that a u to the 1/2. And then you multiply by the reciprocal of that new exponent. The reciprocal of 1/2 is 2. And so then, like always, you should check to make sure, is the derivative of this equal to what we had here? So the 1/2 and the 2 would cancel out, u to the power of, subtract 1 from the 1/2, and it gives us the u to the negative 1/2 with that 1/3 still there. So then I substituted the u back in. How are we doing so far? Anybody have questions at the moment? Doing all right? Okay. So then I substituted in that initial condition that they gave us. So I put the 0 in for the x and the 37/3 in for the y, and that all canceled out nicely to get that c equals 4. And then kind of like on the last one, because I had a fraction here, I didn't like working with that fraction, so I just multiplied everything by the reciprocal of that. So I multiplied everything by a 3/2 because then that canceled out the 2/3 here. And then the 3/2 times the 2, you can see I even wrote that there, gives me the 3. And then the 3/2 times my c, which is now a 4. And then I simplified that and I squared both sides, keeping in mind that you have to square this entire side. So I grouped that in parentheses, right? When you square this side, that just cancels out the power of 1/2. But when you square the right side, you have to group it all together. And then I isolated my y and I substituted the 1 in. So what would you guys like to see next? And like I said, I don't have any others that are worked out, so I'll just kind of have to kind of talk through them.
I.
Christine, did you say I?
Yeah, because I and L are similar.
Okay, that sound all right to everybody? I. So let me go to the screen where I can see I.
Thank you for the help, Miss Grassel. I'm gonna go now.
Okay, you're welcome. Okay, so on I, okay, so we've got this dw dt, and because this side here has t's and w's all mixed up, when I go to, let's see, the question is to write the equation of the tangent line to the particular solution. So let's see, do I even need to find the antiderivative? If I want the equation of the tangent line, I'm going to need the slope at the point. So this is the point, right? So there's the t value, there's the w value at the point. And then I will need the, yeah, I don't need to find the solution to this one. Okay, so if I want the equation of a tangent line, I need the slope and I need the point. I have the point. And would you guys agree that this right here will give me the slope of the tangent line at any point on the solution curve? That's kind of what the derivative does, right? It tells us the slope of the tangent line. So I believe we should be able to plug in the 0 to the t and the -7 to the w to get the slope. So what does that give us then? Let's see, the way they write that, they'll go evaluated at 0. And I'm attempting to annotate. This is not easy to do with a mouse pad. Okay, so that derivative evaluated at that value. What'd you guys get for that? Did you guys figure that out already?
Just get -7.
Okay. Equals, come on, my annotation thing isn't working right now. Everybody get -7? Okay. And so this is the point. So then the equation of the tangent line is y minus y1. So y minus the y value of the point equals the slope times x minus the x value of the point. And so that's that 0 there. And that tangent line, as long as we stay close to the point of tangency and the point where x, or in this case t is 1, is going to be kind of close to t equals 0. It's not going to be super close, but I think for the purpose of this, that's what we're supposed to do here. So you could then rewrite this as y equals -7x. Would that be -7? Right? Subtract that 7 over to the other side. Oh, God. Stupid. And then you would substitute in the value to x. Oops. Maybe I should be using a t because that's my independent variable, but I used x and y. Okay, so then I would substitute that 1 into my independent variable x, and that would give me then that w at 1 is going to be approximately equal to -14. Is that what they have for an answer? I haven't looked. It is. Whew. Okay, so we actually say that W is approximately equal to, so I'm changing this to a squiggle. W1 is approximately equal to, because that's not exactly what it's equal to, because we're using the tangent line approximation. It's approximately equal to the value of Y at 1, which is exactly equal to that negative 14. Because negative 7 times 1 will be negative 7 minus 7. Okay, how's that one? Okay. What else would you guys like to see? I'm going to go ahead and clear this. My drawings.
Can we do E?
E. Okay, hang on one second. Okay. Okay, so the point is on the graph of the solution curve to the differential equation. Find the y coordinate such that the point is also on the graph of the solution curve. Okay, so based on that, I think we do need to find the solution. So we are going to do the separate the variables and find the antiderivative. Because this has the x's and the y's mixed up in it, we are going to need to separate the variables and integrate both sides. So I think I might use my whiteboard for this, which again is going to have to be annotating. Okay, I don't seem to have an option for a whiteboard. So I'll go back to that there. And I'll try to get in there what I can. All right. So why don't you guys kind of help me through this here. When you separate the variables, you have what on the left side?
I have that you have dy over 3 minus y, and then that equals x plus 2 dx.
And I usually will write it like this, just with the 1 over 3y times dy. It makes more sense to me for integrating, but I think Mark prefers it the way you said. Oops. Okay, so then you integrate both sides. This right here is like 3 minus y to the negative 1. And if you treated that like we did one of the other ones where I can't remember which one it was, but if you did a u substitution and had 3 minus y to the negative 1 and you added 1 to the exponent on that, it's not going to work. So this is one where you could use u substitution, but this is going to be like a 1 over u. And so the antiderivative of that is going to be your ln u. So we're
Okay.
going to ln of the absolute value of that 3 minus y, and I'm going to kind of jump through the du steps or the u substitution steps here because it's really hard to write like this. So the derivative of the inside function here would be a -1, right? And so because that's just a constant, I multiply by the reciprocal of that. And so I could just multiply this whole thing by a -1. So now I'm just going to check that. Is the derivative of this equal to that? So the derivative of ln something is 1 over that something. So there's that. And then times the derivative of the inside. The derivative of the inside is a -1, which is canceling out the -1 out here. So that checks. And then on the other side, the antiderivative of x is a 1/2 x squared. Oh, the annotation thing keeps breaking on me. And you guys can kind of work ahead of me because this is taking me so long. And let me know where you're getting stuck maybe after this point. Oh, good Lord.
I think it was just that when I tried to get the antiderivative, I did it wrong.
Okay. Yeah,
I didn't make it into the natural log.
Mm-hmm. Yeah, so those are tricky. Anytime you have something in a denominator, I usually will look at it first to see if I can make it a power function and see if I can add 1 to the exponent. And if it turns out that that exponent is a -1, that's how I know it's going to be this ln thing. So it's just a matter of kind of practicing and recognizing. All right, so then you guys know what to do from there. You would plug in the 1 to the x and the 2 to the y to solve for your c. And then once you have that, then you could plug the 2 into the x to solve for the y value that gives you. Okay. So I'll just leave that there and let you guys ask questions if you have them. And what else do you guys have questions about?
I have it on the next homework, but I don't want to get there yet until everyone's done.
Yeah, let's hold off on that one maybe for now. Okay, anybody have another question? Okay, we'll just hang out then, and if you guys have a question, you can ask. I'll keep eating my breakfast.
Okay, actually, I do have a question. So I'm finishing, I don't know how I can show you. I guess I'll just turn it, but so we're on the one that we were just doing for E. When I'm trying to solve it, I found what C was, and then I plugged it into the equation. And I'm getting close to the right value because the correct value is supposed to be 3 minus E to the -7/2. But I'm getting 3 minus E to like the 3/2.
Okay, can anybody that has
Which
done
one?
this problem help out? The one we were just talking about?
Which one was that?
E.
E?
Mm-hmm.
Wait, what part?
Just on, just like the solving part once you plug in the
C?
2.
Because I was getting, I had 2 E's. One of them was -5/2, and the other one was e to the 6. So I made it -5/2, and then a 12/2 to get the -7/2.
I haven't gone, like, I don't know what I'm doing wrong though, because I'm getting -3/2 instead of, and I
Oh, the
don't
5
have
halves?
T's. No.
Hannah, tell me again where you are. I'm going to attempt to write it down on a piece of paper because I can go so much faster like that, and I'll see if I can pick out what's going on for you.
Well, I guess I'm at the end, but it's just I did something wrong somewhere and I don't know what it is.
Okay, let's see. So
Well, I got that C equals, oh, that's what, I see. Never mind, wait. Maybe, I don't know if I got it, but I could.
But maybe. What did you get for C? Say that out loud.
I think I got that wrong. I think I got C wrong. So that's what I'm going to try and fix real quick.
Christine, what did you get for C on that
For
E?
E, I got E equals -5/2.
Anybody else get that? On that E?
I mean, it worked. I got the answer.
Okay, I think I kind of messed that up. So now I have the correct C.
I also got -5/2 for C, or -2.5.
Okay.
And Hannah, if you need help figuring out how, I can talk you through that.
No, I see what I did wrong now. So now it makes sense, and I got the right answer now.
Alrighty.
Thank you.
You're welcome. Okay, if nobody else has another question right now, Christine, what did you have a question on?
I have a question for the Big Ten that's due tomorrow. So I got like 5 of them done, but the other 5, I'm just like, I don't know what to do.
Okay.
So I tried J, got a C value, and that's about it.
Okay, let me share my screen. Do you want, so you want to do J from the Big Ten?
Sure.
Okay.
That's one of them I haven't done, so.
All right. And I'll just do that with Christine for now while the rest of you guys are working on something else. And then if there's another one from the card sort that you guys have questions on, we will get to that after this. So again, this is from the Big Ten, from the, what's it called? The Unit 7 wrap up, I think, right?
Yeah.
And you said J.
So I got a C.
One. What?
I got a C value, but my C value is 0.
Okay.
I have to go. Bye, Miss Grassel.
Okay. Bye, Sophia.
Bye.
Okay, do you want me to, I'll try to write it up and just on paper because I can go so much faster that way.
That's fine.
Kind of talk through that.
I have to go at 10. So I have a
Yeah.
Zoom class.
Yeah, that's what time this ends. I'll try to go fast.
Okay. Because I have like 4 other ones that I just don't know what to do on.
Okay, well, maybe if we can get through this one, that will help.
Maybe. Because I could always email you about the other ones.
Okay, so Christine, the first thing when you go to integrate both sides on the left side, do you have a y minus 1 to the negative 2?
The negative 2. Yes. Before integrating?
Right, before integrating.
Yes.
Okay, so then the integral of that is just going to be a y minus 1 to the negative 1 and then times a negative 1, right?
Y minus 1 to the negative 1.
Because you would add 1 to the exponent. And when you add 1 to the negative 2, that makes a negative 1. And then you would multiply by the reciprocal.
The reciprocal would be?
The reciprocal of the exponent, which is negative 1, and the reciprocal of negative 1 is just negative 1.
Oh, I put 2.
And then on the other side, I have a 1 minus 4x to the negative 3 because the 4x to the third is much easier to find the antiderivative of if I write it as 4x to the negative 3.
Yes.
So then I do the antiderivative of the 1 and I get an x.
Mm-hmm.
And then the antiderivative of the x to the negative 3, I'm going to add 1 to that exponent, making it an x to the negative 2. And then I'm going to multiply the 4 that's already there times the reciprocal of the negative 2, which means I'm going to be multiplying the 4 times a negative 1/2, making that right side an x plus 2x to the negative 2, I think.
I'm really bad at doing that. Okay.
So did you follow all that?
I got the reciprocal stuff wrong. Other than that, yes.
I'm going to attempt to show you my screen here. Can you see that okay?
Hold up. Do I have to put the negative 1 over y?
You do not have to. I like doing that so that later when I go to take the reciprocal of both sides, that makes more sense to me when I see it like that.
Okay.
Because I'm going to have to get that y out of the denominator, so I'll have to take the reciprocal of that.
Okay.
And then for me at that point, that's where I would substitute in that initial condition to find my C value. So I ended up with a C equals -2, I think.
Wait, what would you get?
I got C equals -2. You want me to talk through that?
Well, because I got to 1/2 equals 5/2 plus c.
Mm-hmm.
And then how do I move the 5/2?
So in what I did, instead of turning that into a 5/2, because I had 2 plus 1/2,
Yeah.
see? Well, because I had 1/2 on the left side and a 2 plus 1/2 on the right side, I kind of just subtracted the 1/2 from both sides. So then I had 0 equals 2 plus c. And then I didn't have to worry about that 5/2.
Oh,
1/2 kind of cancel each other out.
I see.
A little bit easier.
Thank you, Miss Grassel.
You're welcome. Feeling better about it, Hannah?
Yeah, for sure.
Okay, good.
Okay.
Have a good day.
Thank
So is
you,
it
you too,
-2
bye.
or just 2?
I got C as -2.
Okay. That makes things so much easier. Okay, I think I can do that from there.
Okay.
And then, is there time for one more?
Let me check with Lydia and Grace, who are still here, to see if they have more questions on the one that's due today. That was at first due yesterday, but it's now due today, to see if they need any more help with that first. So what do you think? Lydia, Grace, do you guys need anything?
I think I'm good. Thank you, Miss Grassel.
Okay, you're welcome. You're welcome to stay and keep listening as Christine and I keep working. I just wanted to make sure you were good with that assignment. How about you, Grace? Or was that Grace? Sorry.
That was great.
Okay, what I just said to Lydia goes to
Yeah.
Grace, and then how about you, Lydia?
For the most part, I'm good, but just to make sure I'm on the right track, real quick, what's the derivative of 1/1 plus x squared?
Oh, that's tan to the -1x.
Inverse tan.
Oh,
Yeah.
Which one is that for? Just for if anybody watches the recorded version later.
F.
F in the card sort. Okay. So again, if you're listening, in the card sort F, when you have to do the antiderivative of 1/1 plus x squared, it comes out to be inverse tangent x.
Nice.
You're welcome. That's helpful. Okay.
All right.
So
Thanks, Miss
Lydia and
Grassel.
Grace, you're welcome to hang out. You're welcome. And Christine, I'll get to another one of your questions now. Okay, good.
Thank you. Bye.
Bye-bye. Have a good day.
I think I did J wrong again.
Okay.
I was trying to solve it,
Mm-hmm.
but then I ended up with y equals 1/2 plus 1. I know that's not right.
Yeah. Okay, so let me. Okay, you were good with C equals -2.
Yeah.
And then, oh, hold on, I think I did something. There's something I didn't fix. Okay, so then I'm gonna try to get the y by itself. So I got rid of the negative first, or at least I was going to attempt to, but I forgot. So then I have a 1/y minus 1 is equal to, I have to erase because I did something wrong, is equal to a -x minus 2x to the -2 plus 2.
Wait, did you say a -x?
Yeah, because I took the negative that was on the y side, on the left side, and I kind of multiplied both sides by a -1.
I see. -x minus 2x plus 2.
Minus
Got it.
2x to the -2, right?
Yes.
Okay. And then take the reciprocal of that. So then it's just 1 over all of that.
Negative x minus 2x, then negative 2 plus 2.
Mm-hmm. And all of
Then-
that under 1, right?
Yeah.
I'm taking the reciprocal of it.
Yes. And then you said, okay. Okay. That's what I did wrong. Okay. And then would you ever just get me started on like maybe C or E, whatever's harder, or F?
Should we look at C first? Or do
Sure.
you look at a different one? Okay. The limit. Okay. So because it does want the limit of h of x, we will need to find h of x. So we are going to need to separate the variables and solve the differential equation.
Yeah.
So this is C, right? Okay, when I separate the variables, I would have a, what do you do when you separate the variables on that?
I did 1 over 2y times dy equals 1 over x squared times dx.
Okay, so I would leave the 2 on the other side. I wouldn't bring the 2 with the y.
Okay.
It doesn't really matter. It just tends to make things a little bit easier. So I'm going to make that on the right side then a 2 times 1 over x squared dx. And then I'm actually going to rewrite that to be a power function. Instead of 1 over x squared, I'm going to write that as an x to the negative 2.
Okay. So you did 2 times 1 over y times dy equals x to the negative 2 times dx.
Okay, so originally the 2y over x squared, I left the 2 on the right side. And so I divided both sides by the y. And so then I ended up with 1 over y dy. So there's no 2 on that left side at all.
Okay.
Okay. And then on the right side, I end up with a 2x to the negative 2 dx.
Alrighty.
Okay. Then when you take the antiderivative of the left side, because it's a 1 over y, it's a natural log of y. And on the right side, I'm going to add 1 to the exponent. And then multiply by the reciprocal of that new exponent, which is just a negative 1.
So it's a negative 2.
X to the negative 1, right? Yeah. Negative 2x to the negative 1.
Plus c.
Correct.
And then I solve for c and then put everything together.
Yeah, and then you would exponentiate both sides to get the y by itself.
After finding c, correct?
After finding c, right.
Okay. So when I plug in the ln for y, the 5 over e, does the ln and the e just cancel out? So just be 5 equals?
Okay, hold on. Let me look at this. So this is going to be ln of 5 over e. Okay. It's not going to be quite that easy.
Oh.
Negative 2. I mean, you could.
Yeah.
I would probably leave that as the natural log of 5 over e. You could use the property of logs and change that left side to natural log of 5 minus natural log of e, because you have a quotient, the log of a quotient. So you could separate that into the difference of 2 logs. So again, you could rewrite the natural log of 5 over e as the natural log of 5 minus the natural log of e. But I don't know that that's really worth it. The natural log of e is 1, so you could change that to a 1, and then it's like the natural log of 5 minus 1, but I don't know that that's necessarily going to help later. So I'm thinking we'll probably leave that as the natural log of 5 over e. We may
Okay.
need to change it later, but that's kind of what I'm feeling right now.
Yeah, because the 5 that they, or like most of them that they let us do on our own are the harder ones.
Okay, on the right side, when you have the -2 times the -1/2, you do end up with a 1.
Mm-hmm.
So we could combine that 1 with the natural log of e, which was 1. I don't know what's going to be better on this. Okay, let's just leave it the way it was for now. And let's say then that c is going to end up being the natural log of 5 over e minus 1.
Would it be plus 1?
I think we had a -2 times a -1/2, which made that a +1 plus c. So then when you would have to subtract that one over, making it a -1.
Well, because when I put in the 2 to the -1 in the calculator, it says positive 0.5.
Well, you need parentheses to do that.
I did.
Well, I know what to tell you. -2 to the -1 is a -1/2. I promise.
It's a positive 2.
What's a positive 2? Oh, you're right.
That's where it was. Okay.
Yeah. And so you're right. We're going to have natural log of 5 over e plus 1 is our c. Okay, so,
This is not a fun one. So then when I like try and like put y by itself, I got y equals e to the -2x to -1 plus 5 over e plus e to the 1.
okay, hold on a second.
If that's correct.
So first you should have that, right?
Wait, let me pin video.
Where all of that is up in the exponent.
Oh, I'm supposed to put all of that in the exponent?
Yeah.
Okay.
And then because those exponents are being added, I could separate that. So it's e to the -2x times e to the ln of 5 over e times e to the first. I could separate it all like that.
But you don't need to?
I don't know. What are we trying to do here? We're trying to...
It just says find the limit of h of x.
Right, as x goes to infinity. So I say let's just leave the exponent the way it is because there's no x's in that part here.
Okay.
What we do have is in the exponent, we have an x to the -1, which means we're going to end up with an e to the power of -2 over infinity.
Okay.
The rest of it at infinity isn't going to matter anymore. So it's the only thing that's significant is I have e to the power of -2 over infinity. So that means my exponent is going to 0, right? Because if I have -2 over infinity, that's like having e to the -0, because anything divided by infinity in terms of limits goes to 0.
Okay.
I'll just write this down. Limit as x goes to infinity of 1 over x. That limit right there is always going to be 0.
Okay.
Okay. And so that means we have e to the 0. So I think that means we're going to have a 1 for that.
The answer is 5, which is what I don't get.
The answer is what?
5.
Okay. So it is 10 o'clock. So I will
Yeah.
work on this and get back to you.
Okay. Do you want to know the other ones I'm struggling on or
Yeah.
no? I'm also stuck on E, F, and I.
E, F, and I. Gotcha.
Yes.
Alrighty.
Thank you very much, Ms. Grassel.
You're welcome. Bye-bye.
Bye.